We've all been here before, and it's okay. These things happen to the best of us. But together, we can help stop accidentally lighting everything on fire while trying to develop a pulse jet engine driver circuit.
What?
Obviously, explosions can be quite dangerous, which is why it's best to get far away from them. Usually you do this with electric ignition, i.e. a taser for lighting fires. Now, I did try to just buy a taser, but apparently they're a dangerous weapon and illegal, but I think I found kind of a loophole. It's basically just a taser. How is this related to physics again? Circuit diagram, because this is not just an excuse to buy a taser and explode things. The main part is this one here, which is an ATtiny84A microcontroller. You can load code on it and get it to do pretty much anything you want. I'm gonna make it act as a timer, so it'll have a countdown, and then the bomb or whatever will go off when the countdown reaches 0. The rest of the circuit mostly consists of these 7 segment displays to show the countdown, some buttons so you can actually set the timer, and the switch for the not a taser. That switch thing is a power MOSFET. It uses a small current at its base to switch a larger current between its source and drain. We need it because the microcontroller pins can only really handle 20 milliamps. The igniter needs 2 full amps. If you remember from our physics worksheets, things can have internal resistance, and the microcontroller is kind of the same way. We can use V equals IR to figure out that its effective internal resistance is about 260 ohms. The buttons are connected to a resistor ladder, which basically makes a different voltage at every point. Each different voltage can go to a button, and then when you press that button, the common line here will get a signal to the microcontroller. And since the microcontroller can take analog inputs, it can tell the difference between this button, which might be at 1 volt, and this button, which might be at 3 volts. However, you'll notice if you press 2 buttons at the same time, you'll completely change the resistor network, and it will probably get some weird in-between value. So to fix that, you can add some diodes in between the buttons and the common line, so there's no buttons going back into the other buttons and breaking everything. The 7 segment displays are connected to these shift registers through some 1K resistors to limit the current. The shift registers basically convert serial data to parallel data. They're just needed because the microcontroller doesn't have enough pins by itself. Now I have to actually go build this thing. I think this thing's finally done. You can turn it on with this key switch, and then it'll do a little boot up thing, and then you can set the timer using these buttons. So far, it's been working pretty well and should be ready to actually start blowing some stuff up. Believe it or not, as a miner in Canada, it's actually pretty hard to get access to explosives. So instead, I've come up with an assortment of items I should be able to use to make hydrogen by ripping the hydrogen and oxygen apart from water. So we'll see how that goes. My power supply isn't quite powerful enough to do water electrolysis, so I'm gonna add some salt to this water to make it more conductive. If you're doing this indoors, I would recommend against it because you'll probably end up making chlorine gas, which was fairly effective in World War I. Anyways. Okay, basically what I've got set up here is high current power into the water, spark wire into the box. See if it works. So the Pringles can wasn't that interesting, but the second explosion in the jar worked really well. It made a pretty cool fireball. Looking closer at this explosion, I estimated the height the jar lid went to be around 1.2 meters, and that it weighed around 0.36 kilograms when combined with the weight of the wire it was attached to. Using change in energy potential equals mass times gravity times height, I came out to a change in energy potential of 4.24 joules. And this is absolutely nothing, especially when you consider how much energy it took to make the hydrogen. Using power equals change in energy over change in time, you get around 48,000 joules, since it used 100 watts over around 8 minutes. And that's terrible efficiency. It came out to 0.009%, which is it's really bad.